C# 10 and .NET 6 with Mads Torgersen.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. ClearMeasure is hiring architects as well as .NET engineers who would like a path to become architects. And finally, be sure to check out the new video show, Architect Tips, as well as register for the Dev Intersection Conference in Las Vegas, December 7th through 9th. And if you use the discount code Palermo, that's Palermo, then you can get a discount on your ticket. And it's exciting to have a national in-person conference coming up. Now, I'm excited about our guest today on the show. We have Mads Torgersen back. He was on episode 46 prior to this, and he's the lead designer of the C# language, and he's been at Microsoft for 16 years. Mads, welcome back to the show. How are you, sir?
Thank you very much. I'm doing great.
Awesome.
How are you?
I'm good. We were kind of reminiscing 2 years ago. It went by in a snap. It doesn't seem that long ago.
Yeah.
But, well, you know, there are lots of people who are familiar with your work because you've been running the show with the C# language kind of after you got the handoff from Anders. But for those not familiar with you or your work, or just can you give the brief overview for kind of your journey into this team, and then as being the lead designer of the main language we all use?
Yeah, I started computer science. I took a PhD focused on language design. Then I became a professor for 4 years at that same university. And I got to, through just sheer luck and in many ways, just having things dumped in my lap, I got to play with folks that were doing generics in Java at the time, and ended up getting a little grant from Sun Microsystems to hire some student programmers, and we implemented wildcards in Java, which are a not hugely popular feature, but that was my first sort of experience of participating in real life language design. And then I liked it a lot more than being a professor, so I went and advertised that a bit, and Anders came along, and the rest is history. That's how I got onto the C# team.
Awesome.
And then when we, while we were building Roslyn, the C# compiler in C#, there wasn't really, there weren't resources to add new language features for a while, because we were just trying to stand up a compiler that could do the same as the old one. And so Anders and I went and spent a few years. It wasn't much more than a year for me, I think, on TypeScript, and being on the inaugural design team for that. And then one of us had to go back, and I was happy to do so. With Anders out of the way, I was in charge. Right. That's how we got to this point.
Awesome. Yeah, I remember hearing Anders speak. What was it, 5 years ago? Talking about TypeScript, and he gave a really interesting history of his work on the Delphi language, and then it's talking about a few features that he liked, and so he wanted some features similar to that. I mean, just connecting all that history together with multiple languages, kind of fascinating. How Microsoft now is what can I say, taking over JavaScript with TypeScript, and now even non-Microsoft developers are loving using TypeScript and Angular and other things.
Yeah, I don't know if takeover is the word I would use, but definitely, I mean, I think first of all, we came to TypeScript with an open mindset from the start. This was a project started by Microsoft, but it's been open source for nearly all of its time, except those initial months where we weren't public about what we were doing yet. So TypeScript has always been more. I mean, it is strongly rooted at Microsoft, but it's been rooted in also being for the whole JavaScript community, regardless of where you are and which companies you happen to align with or not align with from the very outset. And I think that's been a big part of its success, is that it just tried to take the challenges that JavaScript programmers had and addressing them with types. Just how are they programming? Well, what kind of struggles does that lead to? Because you can do many weird things in JavaScript, and it's like, can we come up with some types for that? And that's pretty much been the rinse and repeat of TypeScript ever since.
Well, we're here to talk about C# and the next wave of C# 10 and .NET 6, which is coming out in November. It's going to be here before. At this time of this recording, we're just 3 weeks away from the big release, roughly.
Something like that, yeah. 3-4 weeks, yeah.
And the plans are all public for people who are already paying attention and whatnot and using the previews. And now the release candidate is out at Visual Studio 2022. But what, in your mind, as being the lead designer of the language, what are you most excited about? What are for you the coolest things in the next C#?
Well, I think that there are several good things in there as always, but one thing that I really love is that we have, over the last couple of releases, including C# 10, we have doubled down on a theme of simplification, where C# has many, you could say, idiosyncrasies with it from what programming languages looked like in the late 90s when it was first dreamed up. And we've done many like nip and tucks over the years where we streamlined it more and made it nicer in many ways. But that's something we really doubled down on, saying, hey, it's okay for us to sort of change the face of what a C# program looks like, almost, to be much simpler and more in line with what modern programming languages do elsewhere. We don't have to look like an old language. We can make these changes, and by doing that may, it moves the cheese for people who are used to things looking one way, and that's a real hurdle. But on the other hand, it makes C# much more approachable for people who grew up with other languages or who are new to programming. And so both in C# 9, which came out last year, and this year again, we did and are doing several features that are mostly about just putting less things in your face and making the simple things simpler, leaving complexity for when you need it. And that's a coordinated effort between us and many of the library and framework teams as well. And if you look at ASP.NET in particular, they're making huge strides this time around in close collaboration with us in the language team to make the experience much simpler, much more approachable for when you just start out with ASP.NET, and even for many of the common scenarios where you don't need to reach for the for the heavy tools. Just don't even worry about the heavy tools until you need them. Leave them on the shelf, and that's the thing I want to stress the most. That's something that's really close to our hearts. Yeah. And it does mean that, and many people point this out, it means that C#, we are deliberately giving you more ways of doing the same thing. So C# as a language, as a result of making the developer experience simpler, we are making the language, in a sense, less simple because there are more choices in there. That's something that we're looking at and thinking maybe it's time for us to lean in more into the kind of steering people in the right direction with what part of the language is actually modern C# and what part is more like legacy C#. And coordinating that a little more between tooling, documentation, and so on. And that's a process that we're only starting on. That's not like a big new thing coming out in .NET 6, C# 10, but that's sort of just like looking forward. I think that we need to think about having a coordinated view of what's the C# that I should be using all else equal, so that it's easiest to learn, gives you most expressiveness based on everything we learned over the last 20 years and so on, rather than starting with C# 1 and working your way up.
Yeah. Well, let's dig into a few of those simplifications. Dan Roth was on the show just a few weeks ago talking. The simplified minimal web APIs were one of the things that he was talking about. So maybe just drill down to a few of the simplifications, whether it's a console app or just namespaces. What are some of the ones that, in your opinion, are going to kind of reduce code in every code file across a common code base?
Yeah, well, last time in C# 9, the big one we did was top-level statements, which means that you can write a program as just a series of statements, at the top of the page, at the leftmost indentation level, and that's your program. You don't have to have a main method of a certain shape that sits in a class and so on. So that was sort of the first step in that direction. This time we're doing things to shrink your programs vertically as well as horizontally. So to start with the horizontal shrinking, there's just a simplified syntax for declaring what namespace you're coding in. This is a super simple language feature. You can just say namespace blah semicolon at the top of your file instead of open curly, and then everything that comes after that is just in that namespace. And that it only saves you 2 lines of code, and you're probably going to use one of them for a space, but it saves you a whole lot of indentation, right? Mm-hmm. So it means that your whole program isn't indented always. It's just at the top of the file, which it's just remarkable how much lightness that gives already. And then the other big culprit is using clauses at the top of files. Every file in C# today has to have its own usings, and you either you keep all the usings that the template put in to begin with, and then you have some of them are grayed out because the ID is telling you don't really need this. I don't know about you, but that triggers me. It's like, why do I have to have these things if I don't need them? And then I go and remove them, and then it turns out like an hour later I need them, and I put them back in, right. And they end up being different across all the files in some semi-random manner. I just want them to be. The only reason I'm cleaning them up is because they're in the way, right? There's all this goop at the top of the file. I want to just put them somewhere where I'm not looking, unless I care about usings. And so that's what global usings do. They allow you to declare usings that apply to the whole program, across the whole assembly or project. And you can, the typical way you would use this is you can go and make a dedicated file for it. Global using system, global using system collections generic, and so on. Just all that stuff goes there. All the stuff you like to use goes there, and then it just applies to all your files.
Now, is that only at the assembly level, or is it also a namespace level in a particular folder structure?
It's only at the top level.
Okay.
Yeah, we don't have a way to sort of merge usings across, usings can be put either outside or inside of a namespace. And this is only to the ones that are outside the namespace. Because, we could go and cook up a feature that will magically merge across the namespaces as well. Like over here, I have namespace this, over here, I have namespace that, or the same namespace, and they should merge their global usings and so on. But we're like, you know what? We got the 90-some% case covered here for things you are likely to share across all files. You're likely to share them at the top level. And so, hey, if somebody comes and says, this is actually really limiting for me, that's a new C# version next year. Then we can fix it, we're trying to get better at taking not small steps, but medium-sized steps where we're confident that we're adding value without adding too much complexity. And so this one is just like, yeah, it's simple. It's just like you wrote it in your file, except it's over in that other file, and it can only be at the top level.
Mm-hmm. One thing that from an architect's perspective, I see that as even a benefit to code review of changes, because as a team, we say, we are adopting global usings. And so unless it's a special case, don't put a using in a regular class file. And that way, if I have a data access library, well, my global using, I expect, say, Entity Framework to be in there or Dapper to be in there. And if I have a web API project, then I expect, a JSON library to be in there. And if I'm looking in there and I see other things crop up, it's one thing to review the references, and obviously you can view the references, but the global usings is just another in your face of like, hey, we're making this available, and maybe when looking at that assembly, we say, wait a minute, no, we should place dependency on this namespace or this library elsewhere. Yeah,
I mean that's true, and it just getting an overview of what are you actually depending on here. The using clauses are pretty good. I know that you can fully qualify your way into anything you're referencing, but the usings are a pretty good picture of what are you depending on, because you'll probably import any types that you depend on, and today that's all distributed. How do you gather up evidence of everything that you're depending on here? Well, that's a hassle. But right. If you adopt the discipline of putting it all in one place, which you can now, then that becomes trivial.
How far away are we from, or is this maybe not part of the vision, of just dispensing with namespace declarations and just, if it's not there, inferring it from the folder structure in a project?
That's a good question. I think that the problem with that is that folder structure is not really a language concept.
Yeah, it's one of those .NET conventions that that Brad Abrams wrote about way back when.
So that's a little hard, but we are blurring that line a little bit in some places already. So who knows? The global using that we just talked about, the SDK folks ran with that and said, hey, actually, for a given project type where the templates today would put these usings at the top of every file, instead of, first of all, we could use global usings for that instead. But not only that, we could actually not put the global using file into your spit them as source code that you manage. We could just transparently make them available to you. We just generate an extra file as part of build that puts all the ones that are useful for, say, an ASP.NET template, for instance. Just put them in scope. So they use the language feature that we added to put things in that you don't even have to manage manually. You don't have to manage that one file. They're taking it a step further. And you can imagine, as long as I put in like a separate file in scope and not sort of tinkering with the C# files that were manually written, I think that's totally fair game. And the problem with namespaces is that today, and that'll still be the case with the file scope namespaces, they're in every file. Every file still has to say what namespace it goes into. Maybe one day we could have a global namespace thing that just says all files are in this namespace. And once we do that, then it's fair game for MS Build to throw that in based on folder structure. Then that. But I'm just speculating here. It's not something we have plans for. It's just kind of
it's almost like a pre-compiler step.
Yeah.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast,
delivering quality and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
So with the simplification, we've got the namespace and global usings, but previously you've come out with records and the non-nullable reference types and whatnot. So when you think about modern C# in the version 10 and .NET 6 era, for regular business applications, what do you expect that C# to look like when you take all these new features? Like I'm thinking data transfer objects that exist only to effectively be serialized with JSON and thrown over the wire, versus data access classes, and just when we're using strings and dates, does 80% of our code end up being non-nullable reference types, or what are some of the things you're seeing?
Yeah, first of all, well, when it comes to nullable, yeah, I don't have a percentage of like how much code ends up being non-nullable, but I think so far we've seen confirmation that it's the majority of references end up being non-nullable. In particular, when you're talking about relatively simple data structures that are built up and maybe don't change. Like we put a lot of effort into supporting the scenario of immutable data. You're building things up and they don't change. Well, it's easy to demand up front that things aren't null when you build them, and it typically won't be. The sort of the data transfer object scenario is one that's very much on our minds and was also on our mind. Modeling data rather than modeling stateful objects is something that object-oriented programming has been relatively weak at, and we try to prop that side up without sort of breaking with the spirit of C#, and that's records are a big part of that. Init-only properties are a big part of that, and it's something that we'll probably we'll keep churning on for a bit. There are some scenarios where it's still a little like the interaction between nullable and records can still be a little uneasy sometimes. You want to have these very simple data types, but you want them filled out, but you can't be bothered to write constructors for them because that's not really, you want to use object initializers, and now you're not initializing them in the record declaration, so you get null. You get warnings from the nullability system saying, hey, you have null values in non-nullable things, and there's really no way to force people to provide non-null values, to provide values in object initializers. Object initializers are always optional, right? It's always optional what you initialize. Once people put something in, we can force them to make it not null, but we can't force them to put something in. And so that's one of the sort of the areas where the two features are kind of not fully working together yet, and we're looking at for C# 11 to have a notion of required properties that are not optional to initialize in an object initialize.
Gotcha. So let's take data transfer objects that are always serialized or over a service bus or HTTP. Are you seeing records being the new go-to style for those classes, or is it not as clear cut?
I think that, it depends on what kind of functionality you need from them. The records are really just classes, or now structs with C# 10 as well. You can choose record structs that have some extra bells and whistles. Like all the defaults for classes are tuned for mutable reference equality objects. And if you're in a world where you need to compare by value, and you need immutability and be able to rely on that, and so on. The defaults are really wrong for classes. And with records, we wanted to create a sort of a dialect of class, a version of classes where the defaults were flipped and all this stuff was implemented for you by the compiler. All this difficult stuff like getting equality and hash code right in the face of inheritance, when you want value-based equality that looks at all the members. Well, that's something that you're likely to get wrong if you're writing it manually, or if you don't get it wrong right away, then it doesn't take many months of maintenance and churn before it's wrong. So we build it for you, So if you need those kind of things, if you really want the things to be treated like values, behave like values, then that's what records are for. And that is the case for many data transfer things. If they aren't just for packing bits and sending them along, but also they participate in some program logic, then you typically want some of that.
Gotcha. This is probably out of the scope of the language, but one of the things that I've struggled with, and I've seen so many other people struggle with, is mapping. It's just left-hand, right-hand code, and mapping from one class to the other, where from a human perspective, you look at it and you're like, well, yeah, I don't have to be a programmer to know what property on this new one this other one goes to. It's kind of obvious, but there's still there's no way to say, hey, kind of funge it over to this. We still have to write all this mapping code, but yet in the type converters, we can create our own, say, decimal type and build it up to where I can say, decimal equals my type, and it just kind of works that way. Is that problem ever discussed in the team?
Well, yeah, there's several aspects to type mapping, where you're sort of talking about where you have independently authored types that just ought to be able to fit together more magically, so to speak.
Like the property names are exactly the same on the one versus the other, but we still kind of.
There are a couple of different approaches to take. We hesitate in the language to go to sort of like a structural type system, and that also never really works in practice. If two things were authored independently, they're likely to have enough differences that they won't be similar enough that the language can just say, oh, structurally they're the same type. That's a fantasy scenario. It doesn't exist. So the question more is, how can you, when you want to create a mapping, how can you make it easy? And there are a few different approaches you can take to it. One is sort of outside of the language, where we have put a lot of effort in recent releases into source generators. So because at a reflective level, it's easy to see, oh, these two should map to each other. You can generate mapping code with a source generator that just does the right thing based on the current shape of these types. And so that's sort of like a compile time metaprogramming technology that we have really leaned into over a couple of releases, and that can help with many of that kind of thing. But that means you have some auto-generated code that takes care of the mapping and that updates according when the shape of your types update.
Yeah.
There are various ways to integrate that with if you want to customize various things in manual code and so on. So that's really good. We're seeing a lot of that have success. A lot of people have picked up source generators, a lot more than I think we even dared hope for.
Gotcha. So with the .NET 6 wave, you talked about simplicity. Are there any other themes that we didn't hit on that are coming out in this next wave?
I think from a theme perspective, that's probably the biggest one. We are continuing there's a bunch of feature themes that are sort of gradually unrolling. One of them we talked about was around records and immutability and initialization. There's sort of a bundled up theme that we're co-evolving over the releases. There's a little bit in C# 10 for that. I mentioned struct records, for instance. The choice, you can make the choice to have a struct be a record as well. Another theme that has been unfolding over several releases and will keep going for a while is pattern matching, which started from absolutely scratch in C#7, I think it was, as just this new kind of thing in the language, patterns and pattern matching.
Well, you have to define it. There's probably listeners out there who are thinking, "What is this, a regex replacement? Pattern matching?"
Yeah, I know. So, pattern matching is, how to best define it? It's a pattern is a thing, a program entity that is simultaneously a test. So it can simultaneously test something about a value, and an extractor. It can extract information from that value. It might do only one of those two, but it can do either or both. And now the language can offer you different kinds of patterns that can be used like that. And what that means, like a simple example, is a type pattern that says, a pattern could be string s. And now you can use a pattern in an is expression, for instance. So I can say if some large expression is string s. Previously, you could only say is string. And now you know that thing, which might have been a type object, is a string. But now you're like, oh, now I have to go and get it as a string. So now you have to go and cast it or use an as expression or something. But instead you say is string s. And now the variable s gets declared and it points to the value as a string. So it both tests the type and it extracts the value at that type, as having that type. And there are various patterns like that. We started out with just a few ones in C#7, and we've been adding more and more. And patterns can be used in is expressions, and they can be used in switch statements. So instead of switching just on constants like in the old day, you can switch on any pattern now. So a switch case can have a complex thing at the top saying case, if this thing is a string and its length is 3 and, it has the character B in the middle, you can put together a complex declarative pattern, and then that switch branch will only get taken if that pattern succeeds. And maybe it introduced a few variables so you can get the character on the left and the right side of that B or whatever, So switches are sort of the other place where that can be used. And then we took switches themselves and hypercharged them by saying, yes, that's the good old switch statement, which is kind of clunky. But now there's also switch expressions, which are the 2020s version that is sleek. It's an expression form, so it can be inline in another expression. Many of the syntax elements are shorter and so on. And so combine that with more and more expressive patterns. A lot of your, it kind of changes your options for how do you write conditional logic. Instead of having, big series of if then else's and casts and stuff to unpack something like a data packet that comes in, or that you don't know something that comes in, you don't know what type it is, you don't know what shape it is. Rather than doing that in sort of nested code and trying to keep track of, did I test that up there as well? Or is this case covered down here or whatnot? You can use a switch expression. You get sort of a flat series of cases that are expressed very clearly declaratively. And you even get checking that, all the cases are, that none of the cases are subsumed by a previous case. So you'll get a compiler warning if one of the cases is already covered above. You get a compiler warning if you're not exhaustive, so the things can drop through and you're not covering all the possible shapes and so on. So it's a whole lot of, it really improves the clarity of your code. It expresses the choices you have in a sort of much more ready to read linear fashion. And it also does more checking for you in terms of, when you have to go through and maintain that code, making sure you don't accidentally hide another case that you were meant to hit or put things in the wrong order, that kind of thing.
Yeah. Do you have any numbers for just the tests and code bases that have been updated? I'm assuming that taking advantage of the new features, the numbers of lines of code for the same application go down. Do you have any idea if we should expect 5% or 50%, or we just don't have that data yet?
That would be a fun investigation to do. And there's probably we love the public GitHub repositories because they allow us to go and see what are people doing. But yeah, you could probably make some fancy queries that would say the more people use the new features, the shorter the code is. But it's hard, because you sort of have to observe a given code file, source file evolve and become shorter. And we haven't really leaned into getting good numbers on that.
Okay. And then I guess finally, as our time wraps up, I've got to ask a question that just gets tons of discussion still to this day. And I think people are just wrestling with how they should be managing it. And that is the async keyword, and how, they find that, okay, I'm using a library or a framework feature where I'm going to be calling a method that's async. And so now I either need to kind of block and wait right when I call it, or make my own method async and then carry that through. And there are some people that's like, yep, that's the way it is. Every method everywhere in your code base is now async, versus the looking at it's like, is that really the answer? So as the lead designer of the C# language, obviously the answer is it depends, but is there an 80-20 rule guidance that you can give there?
I think that it comes down to, I think that this is a question of inherent complexity in async code. When we built the async feature many years ago, I was already around, and and we talked about accidental versus inherent complexity a lot, because the way people did async before we added the feature was with callbacks, and it was very error prone, and it had a lot of accidental complexity that had to do with the fact that we weren't giving you good features for managing asynchrony. You sort of had to stitch it together by hand. But asynchrony is also something that has a lot of inherent complexity. Like when you have synchronous and asynchronous code interacting with each other, that is just an inherently complex situation. And I think what we did with async and with the task and task of T types underlying it and being used in the libraries was to raise that up to concepts that were first class in the language, so that this kind of conundrum that you're mentioning, you could even sort of clearly talk about what it looks like. That it's the inherent complexity now comes to the front, and we can discuss our options and on clearer terms. That's what the async feature did. And I think it is an inherent conundrum. If you're running synchronous code and you want to wait for something asynchronous, well, you got to figure out, it's a real choice you have to make. Do you want to now yourself become async, and then somebody else has to make the choice when they're calling you, or do you want to block and wait? And both things are easy to do now. It's really just a matter of what matters to you here. And the guidance, there is guidance around it. I encourage looking up some of Stephen Tobe's old blog posts, and other folks in the community like Stephen Cleary have good posts and guidance around how to best manage the inherent complexity of asynchrony. And I can't give you like a rundown here, partly because I've forgotten most of the details of their wisdom. But I think my slightly evasive answer is we made it easier to make the choice, but you still have to figure out what choice you want to make.
Mm-hmm. Well, I think you said one thing that seems like a clear answer for a lot of cases, and that is deciding. It's not just, the compiler is telling me that I have to mark my own method with async because I'm calling an async method. It's like, no. Do I really want this code in my method to be a part of that closure to run asynchronously at another time, or am I running this code now? And just have to manage this library that has to have this embedded callback.
Yes. Yeah.
I think that's a really good, in my mind, that's a really good, clear way to make that decision. Because in a lot of cases, when it's just regular code that's creating or managing some entities, and then a little bit later you're going to throw them an entity framework. It's going to save it to a database. And inherently, when you're at the boundaries of the application, okay, there's libraries that I'm working with that are implemented in async fashion, but inside my application, it's a lot of synchronous code.
Right.
So,
but you do want to know, did the thing finish? Did the async thing finish? And sometimes you don't want to move on until it did. And that means, well, I guess I have to block because I'm synchronous. And the only thing I can do to not move on until they're done is to not move on until they're done and block this thread. That is
right.
So it's kind of, it's simple, really. It's just that the choice can be hard to make. It's more about, what do you want to surface to people calling you? What do you want them to see?
Mm-hmm. Yeah. Now, isn't it a really exciting thing with WebAssembly now to have C#10 running inside web browsers everywhere? Is that like hit home?
Yeah. I mean, with Blazor and everything, we're definitely leaning into that. I think over time, WebAssembly will more and more be or become or evolve into just another platform that many languages target. Which I think is a good thing. I think JavaScript has had a monopoly in web browsers for decades, and it's not healthy when something has a monopoly like that. It's for many people, it's a second programming language that they have to learn just so that they can stand up web fronts on the stuff that they otherwise write in C# or in whatever other language they're in. That's an inconvenience and an impedance mismatch between the layers and so on. I think it's good if we can, ease our way together, all the programming languages, towards a place where that's just not a concern anymore.
Mm-hmm. Yeah. Well, awesome. So as we wrap up, you mentioned some resources that we'll include links to in the show notes. Is there any other links or other places that folks should go to immediately if they really want to follow up on what we talked about?
It's always good to go. Docs.microsoft.com has excellent C# documentation and already talks about what's new, even in upcoming releases. That's typically a good place to start if you're mostly concerned about, as a developer, what'll happen to my C# or what just happened to my C#.
Right.
If you're interested in the discussions going on and so on, you can go to the .NET C# Lang repo. That is where C# is designed, and that's where we do all our stuff. The C# language designers do all our stuff. That's our artifacts. They live in there. So that's lots of discussion about features that don't exist yet, and people are proposing and discussing features. But that's much more.
GitHub.com/.net/.net/C#Lang. All right, perfect. Well, Mads, thanks so much for coming on the show and telling us all about C#10.
It's always a pleasure.
Awesome. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.